8.2b is about quotients of powers. So we'll be dividing with powers. Okay, so here's the first rule, well, really the only rule. And it says that if you have a division problem inside of parentheses, and then you have an exponent on the outside, you just take the exponent and you distribute it to the numerator and to the denominator. So in this problem with numbers, like we would take this power of 7 and we put it on the 3 to make 3 to the 7th, and we put it on the 2 to make 2 to the 7th. So for our first problem over here, we're going to take the exponent of the 3 and we'll put it onto the 1, making 1 to the 3rd power, and we'll put it on the 2 and we get 2 to the 3rd power. You could leave the problem like that, or you could calculate that 1 times 1 times 1 equals 1, and then in the denominator 2 times 2 times 2 is 8, and you could put 1/8. The reason it works is because the 1/2 to the 3rd means 1/2 times 1/2 times 1/2, and the way multiplying fractions works is you just go across the top. So 1 times 1 times 1 is 1 to the 3rd, and 2 times 2 times 2 is 2 to the 3rd. That's what's happening. Okay, so here we would take the power of 3 and put it on the x and put it on the y. X to the 3rd over y to the 3rd. In this problem with the power of 2, we're going to first put it on the negative sign, and 2 negatives will cancel each other out. Then we would put it on the 7 for 7 squared in the numerator, and on the x for x squared in the denominator. In number 4, I'm going to take the exponent of 3 and put it on the negative. 3 negative signs will keep 1 because it's an odd amount. We'll put it on the numerator to get 2 to the 3rd, and on the denominator to get 3 to the 3rd. Okay, here, this is a little different. So when we take the power of 5 and we put it on the numerator, there's already a power there. So remember that we would have to multiply those two exponents, and we'll get a to the power of 10. And then in the denominator, it's just going to be b to the power of 5. In number 6, you want to be a little careful about this because we're going to take this exponent of 2 and we have to put it on each thing. So first we'll put it onto the 2, we'll get 2 squared. Sometimes people forget that one. Then we'll put it on the z that already has a 2, so that will become z to the 4th. And then we'll also put it in the denominator on the 3 for 3 squared. Okay, for number 7, we'll take the exponent of 4. 4 negative signs, it's an even amount, they would be gone. We'd have 2 to the 4th in the numerator. There's already a 3 on the x, so that's going to become x to the 12th. And then the denominator will become 3 to the 4th. In this problem, we're going to take the 5. You try it, and I'll just write down what I get, and you write down what you get. See if you got 2 to the 5th, a to the 45th, over b to the 35th, c to the 15th. And then for this problem, we need to do it in parts. So first we're going to take the exponent of a 3 and put it on the 2 and the s and the 3 and the t. In the second fraction, I'm just going to drop that fraction down. We're not changing anything right now. And then I'm going to look at this problem and see, is there anything that we could simplify by combining or canceling? And the only things that have the same base are the t to the 5th and the t to the 3rd. So what would happen here is we would take the top exponent of 5 and subtract the bottom one of 3. These 3 t's would cancel out 3 of those, and we'd be left with t squared in the numerator. The other things we can't put together because they don't have the same bases, so we could leave the problem just like this. It's also possible that you could figure out what the numbers are equal to, and you could write out the numbers if you wanted to, but you don't have to. And that's it. So you'll want to be sure to send me these notes. Take a picture and send me those notes.